morning, everyone, and thank you for joining us today in this webinar. So my name is Virginia Ruiz-Villanueva. I work as an assistant professor at the University of Lausanne in Switzerland. I'm a fluvial geomorphologist, and one of the main topics of my research is the dynamics of large wood. So I have been working together with Hervé over the past 8-9 years. And today I would like to show you some of the studies we have done at the Génissiat dam. So first of all, a few words about in-stream wood at dam reservoirs. So here I show you the outcomes from a study in Switzerland where a questionnaire was distributed to 60 hydropower operators, all of them dams with reservoirs, so no runoff power plants. And the questionnaire asked them about the accumulation of wood. So if there was wood arriving to the dam and what type of management measures they applied, and if they had problems or any damage due to the wood. And as you see in the map, so each point is the location of each dam. Most of them are in red and orange colors. So these are the dams where wood arrives frequently. And as you see, in most of them, more than 80% of the dams had some wood arriving, and in more than 70%, they have to remove the dam periodically. And also 20% of them reported damages or problems because of the wood. So as you can see, this is an example from Switzerland, but this applies to other regions. So this is a common issue, and I'm sure the managers that are listening us today, they are very well aware of this problem. So what are the problems when the wood arrives to the dams? So as you can see, during floods, usually large quantities can accumulate and form these rafts. And what happens is that they create an obstruction of the dam crests or gates, and this obstruction may significantly reduce the discharge capacity of the dam and may also cause higher water levels in the reservoir. So what is usually done, well, there are two approaches. One could be the redesign of the dam spillway, which is not always feasible, or the other option is to take measures in the reservoir, so retaining the wood upstream or extracting the wood from the reservoir mechanically. And this is usually the most common measure. So at Génissiat, as you have seen before, the dam is, so all the wood arriving to the dam is blocked. But this also offers us the possibility to analyze this wood. And as Hervé said, there is a lot of information we can extract from this wood. We just need to develop the right methods to study or to extract this information. But what are the main questions or the major questions regarding in-stream wood? So the first question, if we see a picture like this, if we go to Génissiat and we see all this wood, would be where does the wood come from? And this might sound like a very simple question, but we really don't know, because wood is not coming always from the same tributaries, as Hervé has just explained. So knowing the origin or the sources is very important. Then the second question is how much wood we can expect. So how much wood could arrive. And again, this is really important to design the proper management measures, but also understanding when the wood arrives or what type of floods are supplying wood is really important, and help preparing and preventing damages, of course. And one major question for managers is also regarding wood buoyancy. So for how long the wood may float before sinking. towards the bottom of the reservoir, so they may know how much time they have to extract this wood. And finally, to answer all these questions, we just need to look at the wood. So the wood has the answers. And as I said, we just need to develop the best method to extract this information. So in Génissiat, we have followed the reversed order. And this is also the structure of my presentation today. So looking at the characteristics of the wood, we try to answer the questions for how long the wood will float, how much wood we can expect, are larger flats supplying larger wood pieces and larger quantities, and where does the wood come from? So just to refresh what Ray just showed, most of the wood arriving at Génissiat comes from the Valserine and the Ar, the main two tributaries, and not a lot comes from the Rhone itself because of the Geneva Lake retaining most of the wood upstream. So the hydrological characteristics of the tributaries are very different. The Arf is much larger, is up to 2,000 square kilometers, is partially glaciated, so the regime is influenced by the glacier and the snow melt also, while the Valserine is smaller and the regime is basically pluvial, so is mostly influenced by precipitation. Another contrasting characteristic, which is important for the production of wood, is the area covered by forest, and the Rhone, the part of the Rhone that contributes to Génissiat, is 30% forested, and most of the trees are broadleaf trees, so riparian vegetation, while the Ar is also around 35% forested, but most of the trees are conifers, conifers and mixed forest. On the other hand, the Valserine is much more forested. It has a 70% of the area covered by trees, but the species distribution is different. So a third of the forested area is mixed forest, third of the area is covered by conifers, and another third covered by broadleaf trees. So all the arriving wood at Génissiat is fully trapped. So there is no way the wood can go downstream. And the Compagnie Nationale du Rhône has to extract, to remove the wood when the raft becomes too large, which is usually after flood events. So this may happen once or more than once a year. And then the extracted wood is stored near the dam. And so since 2013, almost every time after an extraction, I think we missed maybe 1 or 2 extractions, we went to Génissiat and we went to the pile and took several pieces of wood. We measured the size, we weighed them, and we identified also the tree species. And now I will show you what we did with this information. So the first question we wanted to answer was related to buoyancy. And so buoyancy is controlled mostly by wood density. And wood density depends on many factors. So basically depends on the tree species, the wood type, the age of the tree, and the decay status or the decomposition of the wood, and on the water, the moisture content. So we compared the density of wood arriving at Génissiat with wood, with green wood, so wood that we obtained from freshly cut living trees. And as expected, we saw that the density of in-stream wood was lower. This means that the wood that is arriving at Génissiat is in most cases partially decomposed or decayed. But this was really good information because unlike in forestry research, wood density is not really assessed in aquatic studies. So we had some information on that. And this is important because buoyancy controls if the wood will sink and when, so how fast, but also the transport. So we saw also that in this graph, you have a transport ratio. So from 0 to 1, if all pieces are transported through a river reach, means, so this will be the transport ratio equal 1. And then on the other side of the graph, you have the density. So you see that if the density increases, the transport is reduced. So if we have lighter pieces, decayed pieces upstream from Génissiat, this means that they will be more easily transported. While if we have fresh trees recruited, it will be more difficult to them travel the distance to Génissiat. So we put some samples in tanks with water, and we measured them every few days, and we observed the sorption, the water sorption processes. So 2 processes, wetting and drying, but here I just show you the absorption process, so the wetting and how the wood gain moisture. And what we observed is that most samples were sinking to the bottom of the tanks between 62 and 143 days after the experiment began. So the wood is not sinking immediately. It needs some time to gain enough moisture and increase the density before it goes to the bottom. But we observed also that this is a species dependent and decade dependent. Again, we compared the Instream wood with green wood. And what we also observed is that all conifers were still floating. So none of them were sinking to the bottom of the tanks when the experiment finished. So it's really important to know which type of wood will arrive to the dam, to the reservoir, to define when the extraction should take place. The second question is regarding the volume of wood that can arrive to the dam. And so in this graph, don't see my pointer, I think. Yeah. So in this graph, what you have is volume of wood, not arriving to a dam reservoir, but transported during a flood, and then versus the catchment area. So first observation here is that the dispersion of the data is really high. This means that the variability is very high. So similar catchments, similar sizes, and similar hydraulic conditions may result in a very different volumes transported or supplied volumes of wood. And this is in the Rhone River, for example. So this is explained because it's not only the discharge or not only one single flood what matters, but also the flood history, so the previous floods, and even more important, the wood availability. So again, we looked at the different tributaries to understand which one was contributed to wood, and depending on where, when, and where the flood happened. So what we observed is that the relative contribution from each tributary might be similar. for example, in the cases in 2016 and 2017, in this graph, what you see is the discharge contribution in percentage from the Valserine, the Semin, the Rift, and the Ar. And you see that the bars are quite similar. So this means that the conditions were very similar. But if we see the volumes of wood, they were quite different. For example, in April, there was much less wood than the following floods. What we see also is that very or quite similar volumes, like in November 2013, July, and February, similar volumes were also produced with very different hydraulic conditions or flood conditions in the catchment. So again, if we look at the contribution from the different tributaries, this was very different, while the volumes that arrived at Génissiat in some cases were very similar. And finally, if we look at the highest volume of wood extracted between 2011 and 2017, we still need to update this graph and this information with the most recent floods. So in July 2015, we had a very large amount of wood. And if we look at the contribution from each tributary, we see that the flood mostly affected the Give River. So in summary, we observed that similar flow conditions with similar contributions from each tributary resulted in different wood volumes at the reservoir. And we also looked at the sizes, the size of wood, the diameter, because nowadays most of the wood is cut, so the length is not really giving us a lot of information. So when the wood is extracted from the reservoir, the pieces are cut with a chainsaw most of the time. So we just looked at the diameter. And so what you see here is the diameter measured over time. And again, you see there is a large variability, and this depends again on the different species. But we can see here that, for example, the largest event in 2015 didn't supply the largest species, which were observed the previous year. So larger floods are not always supplying larger wood pieces, although they supply larger quantities. So this was something that we expected. So trying to improve this relationship that Hervé showed you before, to be able to predict the volume of wood based on this chart, we now have more observations, so we can relate the volume of wood arriving at the dam with the discharge at the different tributaries. And so we have a very good relationship. If you see this line, it fits quite well, but this is strongly influenced also by this event in 2015. And as you see, we lack data, at least for this period that is covered by these points here. So as I said before, we need to update with the last couple of years. So we lack information in this range to make this relationship robust. But in general, what we see is that the larger floods actually contributed with the larger volumes of wood. And so when we try to combine all the information, we analyze this in a multivariate mode. So in this graph, what you see is the combination of the different volumes extracted over time. So these blue dots are related to the wood volume during the different extractions, and the red triangles are the discharge registered at the different catchments and combined also. For example, we have here the sum of the GIF and the AR. So what we see in this graph is that, for example, the flood in 2015 or the extraction, the volume in 2015 is closer in the graph to the discharge observed in the GIF and the ARF. So it's another way to confirm what we saw before with the contribution from each tributary. So the wood arriving at Génissiat depends very much on the contribution from each tributary. But as I said, also depends on the antecedent flows and the wood availability along the river corridor. So if we look at the trees that are supplying this wood, we can also understand or infer where this wood has been produced along the river corridor. So the distribution of a species is different if we are closer to the channel than if we go farther away or higher in the catchment. So usually we have willows, poplar, and alders closer to the main channel. Then we have oak and ash a little bit higher up on the flat plains and terraces. And then usually on the hill slopes or the high tributaries, we have conifers. So if we know the distribution of a species in the wood, we can understand if the level of the flood or if the flood was affecting only the nearby areas, so just flood in the riverbanks, or if the flood was big enough to inundate the terraces, or if it went higher. So in this graph, what you see is the number of species, also of species and the species distribution. So most of the wood arriving at Génissiat is composed by alnus, so by alder and salicacia. These are willows and poplar trees. So of course, these are the trees that grow closer to the channel. So this is again expected, but we have also a large amount of ash trees, so trees growing a bit farther away from the main channel, and we have also a large amount of conifers. And as we have seen before, the ARF is the major supplier of conifers, or this is what we assume. So if we have more, if we distribute the species distribution over time, we see that this changes. It's not always the same. So we don't have always the same proportion of species in the pile. So if we look at the ash trees, Fraxinus, we see that again, this changes, and we assume that this is related to the flood magnitude. So if we have more Fraxinus, we can expect the flood to be larger. While if we have conifers, as I said, the major supplier of conifers is the ARF. So we can assume that then the flood mostly affected the ARF tributary. Another ways to infer the origin of wood will be shown by Javier just after me, so I will not go into details. And then with all this information, how do we manage Instream wood? So here I show you some guidelines proposed by the Swiss Committee on Dams in Switzerland. So they recently, or 5 years ago, they published this report in which they summarized some of the main aspects related to the management of wood in dams and reservoirs, related to the design of the spillways, the blockage probability, but also the potential measures, and I will not go into details because we don't have a lot of time, but they basically propose a strategy that collects the information on the dam and the spillway, the potential impacts, so the type of floods, the return period, the estimation of the wood potential, and other characteristics of the dam, and they assess the potential hazard related to wood according to all these characteristics. And basically, they propose 3 strategies. So the spillway adaptation, the large wood retention, or the passage of wood. And one of the major conclusions in this report is that if conditions allow and the design of the dam allows, it is desirable to enable the passage of wood. Of course, this is not possible at Génissiat, but and this is also related not only to the management of the wood, but also to the ecological impacts that the retention of wood may cause. So not specifically focused on dams, but on wood transport in general and related hazards in rivers. We recently also published some guidelines or also the outcomes from a scientific project in Switzerland, and the report is available in French and German. And in this project, we proposed different methods to analyze the origin, also the supply, the sources of wood, but also transport and the potential hazards at infrastructures like bridges. And finally, I would like to just briefly mention that the wood regime could be assessed in a similar way as the flow and sediment regime. So if we consider that there is a frequency of events that supply wood, a volume of wood that is arriving at the dam, and timing and mode, we can also use this regime approach to understand the dynamics of the wood. And there are just few examples of structural measures that we can see in many dams. For example, for the retention of wood, we can use these floating barriers. But when the measures cannot be taken at the reservoir, the retention of wood can also be done upstream using these structures in rivers. A very novel one is this one in the Sihl River in Zurich, but I will not go into details. But one important point is that these structures are not always the best strategy, because they could trigger also other issues. So we really need to understand, or to better understand, how wood is supplied, transported, and accumulated. And we need to, we use this information to design the best strategies. But still knowledge is limited, so we still need to develop the best methods and strategies. And dam reservoirs are unique observation windows, so they provide a lot of information because they retain the wood, and we can take this wood to study it. So we thank the Génissiat managers to share the information, and we call others to do the same. So as you have seen, the wood provides really important information, and just as a summary, wood density, the amount of wood related to the discharge, the distribution of the different species, or the contribution from each tributary provides a lot of information. And then besides other solutions, we can always define retention solutions at the catchment. So we need also to look at the catchment and not only the reservoir itself. And if possible, enable the passage of wood. Thank you for your attention, and I will be happy to answer any question that you may have.
Merci beaucoup, Virginia, pour cette présentation.
Thank you very much, Virginia, for this presentation. And also for sharing with us all of the work that you've carried out in Switzerland, where the question of wood is a very important question and which has been largely studied collectively. I think that you have a good head start on the French community there. There are quite a few questions have been raised in the chat. I don't know if you actually want to ask your questions. So Anita, either translator, will read the questions. Yes. So the first question comes from Hervé Piégé. Oh no, that's the question. Okay. So a question from George Olivari, who's talking about the flood of 2010 in the Nartaby. And he says that in this case, there were a lot of conifers and oaks that were transported and that came from a landslide. So it wasn't a question of plant erosion. So can there be very different origins like this?
Yeah, absolutely. This is a really good question because we didn't mention the processes that supply wood to Génissiat, but so in Génissiat, the wood comes from, as we said, the Arve and the Valserine, and mostly from bank erosion or from the areas nearby the river. So basically the erosion of the river banks, the floodplain, or the islands, the vegetated islands. And we observe only very rarely landslides. But of course, this is different in other catchments. So in mountain rivers, in mountain catchments, landslides, debris flows, snow avalanches, rock falls, they all supply wood. And of course, this changes also the type of wood that arrives to the river. So in that case, the connectivity between the hill slopes, the slopes, and the river is very important. So yeah, this is a very good point. And we also look at this in other sites. Yeah.
Deux questions de
Two questions from Nicholas Rabin. The first concerns the origin of the wood. Can we say that Valserine or Arve, does one of them produce more wood than the other? And is there a combined effect between the two catchment areas?
So I think the two options happened, or the two situations happened. What we have observed so far is that the Arve, and we don't know if the Arve or the Rive or both, is the major supplier of wood. But we have also situations and floods where wood came mostly from the Valserine and the combination of the two. So I think the most accurate answer is that everything could happen and depends on the, of course, the area affected by the flood, and also depends on the previous flood. So if, for example, in 2015, we had this large amount of wood arriving from the Arve and the Rive, and so this left the river without any wood. So the following flood affecting the Arve will not produce any wood or very little. While if the flood affects the Valserine, then will be the major supplier of wood. So it's not really easy to understand the dynamics because there are many factors taking place. So it's not only the single flood, it's the flood and the history of floods and the availability of wood in the river. So we can see the three situations, the Valserine, the Arve, and the combination of the two.
Une autre question, est-ce que finalement les caractéristiques des boisements...
Another question now, the characteristic of wood coverage in the catchment basin, was this analyzed to better understand the link between the wood production and the origins of the wood, the influx of wood and the origin of the wood.
So I'm not sure if I understood. The characteristics of the wood is used to infer.
Pardon. The forest coverage in the catchment basin, did you study this to better understand the origin of the wood?
Yes. We just started looking at the distribution of species in the wood. So to better understand this, we need to look at the forest, of course. So now we are starting also to study more the forest status. So not only the species distribution, but the management measures considered in the forest. The status of the trees is really important. So this is something that Javier will also study during his PhD, and he may also comment on this. But this is also very important. Of course, the source of wood are the trees, so we need to also look at them. But Javier, if you